Good day, panel of judges. My name is Okaito Samuel Ario. I'm here to present a paper titled Performance Evaluation of IAR Prototype Motorized Groundnut Roaster. Introduction. Groundnut is a leguminous oil seed whose seeds are a rich source of an antioxidant known as oleic acid. This antioxidant helps in improving blood flow in the brain and reduce the risk of stroke and coronary diseases. In developing countries, groundnuts are used as a source of proteins for both humans and animals, and also as a cooking oil. Traditionally, post-harvest processing of groundnuts includes shelling, winnowing, roasting, blanching, grinding, and oil extraction. Following oil extraction, the residual cake is processed largely for animal feed and also used for human consumption as groundnut cake, popularly known as kuli kuli. Roasting, one of the most tedious and time-consuming process, is a process by which the food products are subjected to thermal and irreversible structural changes accompanied by reduction of moisture content. It is a heat treatment process used to induce the development of typical color, taste, and flavor, which changes the chemical composition, modifying the nutritional value and shelf life of nuts and other agricultural products. In most developing countries, groundnut seeds are used for direct consumption or for oil extraction. In both cases, roasting is achieved by the use of open pan with or without ash or sand over dry direct fire. The use of rotating drum over a fire source or by the use of microwave or oven means. Roasted groundnut oil is highly preferred because of its flavor and shelf life. It actually stays longer than oil from an unroasted groundnut seed. Now, there are two basic methods used in roasting peanuts. First is drying, roasting, and oil roasting. In dry roasting, heat is transferred by hot air, whereas heat is transferred by hot oil in oil roasting. Roasting of agricultural products generally is affected by roasting chamber temperature, composition and structure of the food particles, and surface area of the food particles, among others. The objectives of these studies is therefore to evaluate the motorized IAR groundnut roaster, thereby giving a basis for improving the machine where necessary. B. To ascertain the superiority of this developed motorized roaster over the pre-existing manually operated groundnut roaster. Materials and method. The major material used in evaluating the performance of the Institute for Agricultural Research IAR motorized groundnut roaster was fresh shell groundnut seed variety Samnut 22. The roasting machine was designed and fabricated in 2019 at Agricultural and Bioresource Department of Ahmadu Bello University, Zaria. Other instruments used during the evaluation process include a variable transformer, an infrared thermometer, a tachometer, stopwatch, and a digital weighing balance. This figure shows the isometric view of the developed motorized IAR groundnut roaster. The machine consists of a structural frame, a fixed cylinder shaped drum with a feed hopper, a shaft attached with paddles for steering the groundnut seed, a charcoal heating chamber, a blower unit, and a power transmission unit, which consists of 4 sets of pulleys and an electric motor. Heat is supplied to the roasting chamber through the conduction of heat from burning charcoal in the heating chamber. The temperature of the drum can be raised to about 900 degrees centigrade plus or minus 10 degrees centigrade. Both the heating and roasting chamber are 1 meter long. The rotating speed of the electric motor was regulated with the aid of a variable transformer. The temperature was measured with the help of an infrared thermometer. During operation, the roasting drum remains static while the paddles are being rotated. The rotating paddles are responsible for steering the groundnut seed for uniform roasting. This picture shows the pre-existing IAR manually operated groundnut roaster. The machine consists basically of a charcoal heating chamber and a rotating drum of about 0.8 meter long. The machine has a chain and sprocket as the driving mechanism for the blower. During roasting, the roasting drum is rotated manually either in clockwise or anti-clockwise direction at approximately 24 revolutions per minute. A helical structure on the inner wall of the roasting drum helps in mixing the groundnut and also conveying the roasted seed. Experimental procedure. Fresh shelled groundnut seeds were sourced from a local market at Samaru area of Zaria metropolis in Nigeria. The shelled groundnut seeds were kept for 24 hours prior to the roasting experiment. Now, after removing of the bad seeds, 10, 15 or 20 kg of the groundnut were introduced into the hot drying chamber. Then the roasting operation was started. That is to say, there are 3 batches. The first batch we use 10 kg, the second batch we use 15 kg, while the third batch we use 20 kg of groundnut seed during the evaluation process. Time taken for each of the groundnut seed to roast was recorded using a discharge stopwatch. The following parameters were measured: initial mass of the groundnut, mass of broken groundnut, effective roasting time, fan speed, shaft speed, and temperature. Performance indicators. The following indicators were used in evaluating the effectiveness of the developed motorized roaster. RC here signifies roasting capacity in kilogram per hour. MR is the mass of the roasted groundnut. T is the effective roasting time. RE is the roasting efficiency. MB is the mass of the burnt groundnut seed. M1 is the initial mass of the groundnut seed. REFF is the roaster efficiency, while Q subscript QK is the heat required to roast the groundnut. Q is the heat transfer rate. MD is the mechanical damage. MB is the mass of the broken groundnut seed. Results and discussion. Table 1 shows the capacity, efficiency, and mechanical damage of the motorized roaster under different loading capacity, i.e. under 10 kg, 15 kg, and 20 kg. From this table, the roasting capacity of the machine increased with an increase in mass of the groundnut seed to a highest value of 101.4 kg per hour at 20 kg. Maximum roasting efficiency of 98% was obtained when 20 kg of groundnut was roasted. There was an increase in the roaster efficiency, REFF, with an increase in mass of the groundnut to a maximum value of 33.77% at 20 kg of the groundnut seed. Mechanical damage decreased with an increase in the mass, hence a moderate mechanical damage of 0.10% was achieved at 20 kg mass. This result is higher when compared with the existing roaster, which has a mean roasting capacity of 55.2 kilogram per hour, and that result of 25.8, 33.0 and 33.77 kilogram per hour obtained by Thaddeus 2004, Kabir et al. And Abdul Salam respectively. This lower output in the case of the manually operated roaster could be attributed to the manually driven design where human effort is required. Table 2 shows the capacity, efficiency and mechanical damage at various fan speed. From the table, the machine capacity increased with fan speed to a maximum value of 406.2 kg per hour at 1400 revolution per minute. Roasting efficiency was fairly constant at 97.6% as the fan speed increased from 1200 to 1400 revolution per minute. A maximum roaster efficiency of 30.8% was obtained at a fan speed of 1400 revolution per minute. Mechanical damage remained fairly stable irrespective of the fan speed. The results suggest a higher fan speed produced higher heat and subsequently higher output. Table 3 shows the capacity mechanical damage at different shaft speed. From this table, the capacity decreased with increase in shaft speed from 25 to 27 revolution per minute. Highest value of 92.5 kg per hour was achieved at 25 revolution per minute. Mechanical damage was stable at 0.14% irrespective of the shaft speed. Conclusion. Performance evaluation of the IAR motorized roaster machine was carried out. The machine output capacity of 101.4, 106.2 and 91.8 kg per hour were obtained at 20 kg, 1400 revolution per minute fan speed and 26 revolution per minute shaft speed respectively. The main output capacity of the motorized machine of 9 to 1.7 kg per hour was obtained, while that of the manually operated 55.2 kg per hour output capacity was obtained. Now, 20 kg mass of groundnut gave the highest roasting efficiency of 98%, roaster efficiency of 33.7% and least mechanical damage of 0.10%. Thank you for listening.